am Cecilia. I come from Romania. This is normal. Actually, I come from a region which is very close to Iași, the place where I have been undertaken all my studies in the academic environment. I mean that I got at the Alexandru Ioan Cuza University of Iași the bachelor diploma and also my master diploma. But of course that when you try to focus on your future, you start to think what decision to take. So my first decision actually it was take the path toward Wuppertal. And at the University of Wuppertal in Germany, I did my PhD thesis under the coordination of Professor Karl-Heinz Becker in a group of physical chemistry department. It was my first contact with whatever real scientific investigations can mean. This had happened somewhere in 1998. And from that time, actually, till 2001, I was working with reaction chamber, which were built in the specific lab. And here the photo, it gives a representative image of the reaction chamber, which Professor Becker built it up together with some engineers and some other colleagues from that time. So on 14 December, if I remember well, 2001, actually I had the PhD title diploma. I decided to come back. I stayed for a while here in Iași. And then, of course, since I was already entering the academic career, I could understand at that time how important it is to undertake also some postdoctoral studies. So actually, I have applied with my own proposals within the 7th framework at the European Union level. Under the Marie Curie action, my first proposal was actually an intra-European fellowship proposal under this framework, and the acronym of the project was ECITAMA. As guest, I had Nikos Michalopoulos from the University of Crete. And if in Wuppertal, I could understand how beauty is to work in a lab, actually in Crete, I started to fall in love with whatever means field measurement. And in Crete, I have been undertaking measurements mainly for gaseous phase and also for particle phase from the atmosphere. Of course, that opportunity I had at that moment with this Marie Curie, it created me other opportunities. So actually, I had the possibility to reach the Cape of the Good Hope, and I think that this was amazing through all my life, and I think it's also the place where I would like to go back. I had some other possibilities whenever I came back in Romania, so I went also to United States, and even though I like many aspects regarding their scientific approaches, I don't know if I would like to go back to United States. It's still something which keeps me a part of this. And since I was mentioning that actually I am appraising the quality of the work they come out quite often, I will start with NASA, because I think that NASA is taking most of the time quite an important amount of credits. And NASA is amazing in telling us a lot about atmospheric chemistry, and not only, as you will see. Since I could have access to one of their movies, I said, okay, why not to start with this? Because actually in this movie, NASA is showing us how complex is the chemistry in the entire atmosphere of the world. It starts with gases. It was ozone. There were some radical species. Then come other gases, hydrocarbons, and this comes a lot also from anthropogenic emissions, from biogenic emissions. At the point we will see how also some chemical constituents from the particle phase, from the aerosols, starts to come through this. And all these colors actually are telling us to what extent the pollution might go in various regions of the world. And why it is important to know all this? Because whatever it is in the atmosphere, finally, okay, we have quite often talking about, in the last time, about the climate change. But it's not only this. I think that the human health should be the most important aspects in this regard. And now we have also the chemical constituents of the aerosols, which started with sulfur dioxide, which is here, which is oxidized to sulfate, and so on and so forth. And then a lot of dust, which comes from different areas. And furthermore, NASA was playing also with colors, with one of the most important atmospheric pollutants, actually the aerosols. The orange color, it tells us about some black carbon. The pink, it's not pink, it is mainly kind of mauve. It is related to dust. The greenish one, it is related to sea salt, since we have quite an important surface of the Earth, which is covered by oceans and seas. And green, light green, is actually sulfate. And if we look over Europe, actually sulfate plays quite an important role. And unfortunately, sometimes dust intrusion, which comes probably from the northern part of Africa, arrives in this location. So the presentation, it will focus not on gases specifically, it will focus mainly on aspects which are related to aerosols, the particles which exist in the atmosphere and which in reality are a mixture of gaseous, liquid, and solid phase with various dimensions, which starts from even from 1 nanometer, where that is the dimension where nucleation starts. The particle starts to grow by different processes, coagulation, condensation, and so on, and they get bigger. So we reach to the point where we have the PM2.5 fraction, the one which is regulated worldwide. And these are the particles with an equivalent diameter smaller than 2.5 micrometer in diameter. Then they get even larger, and these which are of 10 micrometer in diameter, most of the time actually are of natural origin, coming from the dust from the soil surface. So in order to understand the differences, I said, okay, if we imagine that we have a piece of hair, human hair, which in diameter it is between 50 to 70 micrometer, then we can understand actually the impact of these particles, which varies from 1 nanometer up to 10 micrometer and even larger. Of course, here I could include only the particles to which most of the articles refers, the PM1, particles smaller than 1 micrometer, the PM2.5, and the PM10. The deposition velocity is increasing in an inverse proportionality with their diameter. And what's the most important, it is that all these particles actually are affecting our health with each breath we take. Because you see, the larger particles, the PM10, they will remain probably at the nasopharyngeal area, but the PM2.5, they will already go toward the bronchial area of the human lung, while the PM1 will reach the alveolar region. And this is the worst, because actually each of these type of particles are carrying tens, hundreds, probably sometimes even thousands of chemicals, which affects our health. And overall, I think that all these aspects are in direct relation with many of the United Nations Sustainable Development Goals. I will not target any of this now, and I will try to go further. Because, okay, we saw what NASA is doing. Of course, in Europe, there are many big research centers which does similar kind of investigations. But what we did in Iași, actually, and I will start in this way, since backward, if we trace, actually, I had a similar background with one of my colleagues, Professor Olariu. And so we defend the PhD thesis under the coordination of the same professor. And I think that both of us, we have learned quite a lot of aspects from the experience we had it in Germany, in Wuppertal. Professor Olariu was the first applying with a proposal in order to get funding to improve the infrastructure in Romania, and this was called Integrated Center of Environmental Science Studies in the Northeastern region. It was implemented between 2010 2014, and the main result, actually, it was building the reaction chamber. We call it in the short form EC2U because it is made by quartz. We performed a lot of investigations in the gaseous phase, and we get information concerning the chemicals reactivity and also about the mechanistic aspects. And as an important result, actually, the chamber which was built here in Iași at the Alexandru Ioan Cuza University of Iași, it created an opportunity for the university to be traced and included in an European consortium called Eurocham 2020. Over the years, Professor Olariu told me, okay, when there were some other opportunities to get funding in order to improve the infrastructure, because here, this was the major problem. And he told me, okay, look, there is a chance, now try to apply with your own idea. And this was the moment when actually, since I was falling in love with aerosols long ago, because my PhD thesis, it was focused on understanding the mechanistic oxidation of dimethyl sulfide, which is emitted from the marine phytoplankton. So again, at the global level, the impact was expected to be high. And the dimethyl sulfide by oxidation, it forms a lot of sulfur dioxides, which further goes to sulfate and so on. And finally, we find all these amounts in the aerosol phase in the atmosphere. So my idea in somewhere in 2080 to 2090, it was to think on a research center with integrated techniques for atmospheric aerosols investigation in Romania. The acronym is Recent Air. It was implemented between 2020 and 2023. We have half of the Romanian map because actually by building this center through that project, 10 new laboratories were created under the umbrella of the university. Their geographical distribution is easily identifiable from this slide. Of course, the cluster, it is more close to Iași, because Iași actually it is the pool for the researcher, but it is important that we have a research laboratory in the mountain area, and this was meant to be a clean area without too much anthropic influence. We have a laboratory in the rural area. This is Mădrjac, not that far from Iași. Another one, which it is in a more in a seismological area of Romania, Tulnici, and the ninth one, actually, it is in Acigea, Constanța, close to the seaside. And what it does, actually, this infrastructure, which it was built under the Recent Air umbrella, it helps to approach many subjects, starting with the formal sciences, going to physical sciences, life sciences, even social sciences, and of course, even earth and space. There is infrastructure also to get such idea. So furthermore, just few words to show you how it looks like a couple of the infrastructure which was distributed at each of these locations. I will start with the Laboratory of Applied Chemistry in the Atmospheric Aerosol Science. This is RA1. And on the right panel of the slide, actually, I put two instruments which were used for some of the data which I will present in this talk to you. The second lab, actually, it is our field measurement site. We invested quite a lot of time in this location. Of course, the infrastructure was improved only through this Recent Air. And what it is important, it is that this location actually allows us to perform direct field measurement. And there we have instruments to obtain samples, which we bring them back in the lab in order to be analyzed in their complexity. But we have also some instruments which gives us direct measurements. And probably you have heard, or at least some of you have heard about LiDARs and this kind of systems which makes measurements on a vertical profile. The third laboratory, which is related also to chemical investigations, it is laboratory for the investigation of the physical chemical processes of the gas phase with implications in the formation of secondary organic aerosols. And also at this location, we have various instrumentation allowing to discriminate from ionic constituents till organic molecular compounds. I will stop here. At the beginning, I wanted to go through all those 10 units of the Recent Air structure, but I said, okay, no, it is too much. Of course, you have the infrastructure, but then you start to work, do you have really the human resources to go on with this? And our working team is not that big. We are trying to answer several questions. Of course, in our life, we relate mainly to the beautiful parts, even though we have to face also the ones which are very challenging. The photos for me are very nice. Actually, these are colors which I like them very much. But, you know, this is a sunrise from the Ceahlău Massive. It is in the Neamt County. Actually, from Neamt County, I'm coming. And this is a sunset from the Iași urban area, a sight seen from the university. Both are beautiful, but actually they reflect that the atmosphere is quite loaded with probably particles, gases. Of course, there is also a lot of water as vapors, but it is not that it's only a clean atmosphere. And actually, again, the two of us, which many times and quite often we come across the kids with concepts, ideas, and of course, we do also work together with them. We have some co-workers which have and still are doing hard work in the field and also for the laboratory measurements. Some others which are involved in laboratory investigations and method developments. And from here on, I will start with some direct results which we obtain at our investigation sites. At the beginning, again, I thought to make the presentation in a different way, but no, it is kind of more general, but I try to focus on specific aspects which I know that are raising several questions. And for example, in 2024, I have learned that at the European Union level, it was implemented a new air quality directive by the European Parliament and the Council of it. And actually, up to that moment, regarding the particles mass concentration, which is expressed in micrograms per cubic meters, always we related to the previous regulations, which were 20 micrograms per cubic meter for PM2.5 particles and 40 for the other. But whenever this new air quality directive was implemented, actually they switched the volume for PM2.5 to 10, so it is lower, and from 40 to 20. The green distribution and the yellow one reflects the measurements from our side. So actually, probably with the former directives, more or less the air quality from the Iași urban area could be seen as a good air quality. But what we have to keep in mind is that these measurements are actually from 30 meters above the ground level. I used to say that I am afraid to come more down and to start to measure at the normal altitude. The site is great, actually, for the long-range transport phenomena, transboundary pollution, and so on. Moreover, the directive regulated quite a lot of parameters which could be measured. You see that we are referring only to PM2.5 and PM10, but all other parameters, the European Union tells us that they should be measured. Few slides ago, I was telling to you that at AMO station, actually we have instruments which we use to collect samples to bring them in the lab, but there are also some LiDARs. Quite interesting the fact, last year, I have noticed in April that for about 2 weeks, the air in Iași, it was almost unbreathable and very loaded. I didn't have time to talk to the kids. I used to call them kids to go at the sampling station where we have these field measurements to watch for a specific instrument. But suddenly, I think that in December, I asked Georgiana, I was presenting it to you in the former slide. I said, Georgiana, let's go to Amos in order to look what the data from our leader from April was telling to us. Yesterday night, when I was still working on the presentation, this is when the time becomes really precious. It's difficult to finish in specific frames, whatever you have to do. But I was searching to see about these specific events if others were concerned. And I could find this information on March 17, 2025. The European Space Agency was reporting that their data showed that Saharan dust plume probably was starting to come from Libya to Southern Europe. These are data from our LiDAR, aerosol LiDAR, which is at AMO station. I was telling in November to Georgiana, this is amazing, because actually we have quite a lot of information on a vertical profile. At that moment, I didn't know about this, but we have also an horizontal time. Still, we can't compare with NASA. I think that never it will be possible to do this unless we'll find really good people to do modeling in that regard. But all we see in red mean a lot of loading of the atmosphere, moreover turbulences, because these are turbulences, and many other aspects. This it is 14th April, that was 17 March. This is the next day, because everything depends on the loadings of the air masses which comes toward the sampling site. And this is 18th of April, 2025. Again, so the event didn't finish. So I think that taking into account the European Space Agency info and what our instruments gave us, I think that we are pretty okay. But you see, again, when you do not have enough human resources, you do not look on time on that. Also, yesterday night, I found exactly for 14 April 2025, Ager press from Romania saying, a mass of air carrying Saharan dust particles will pass over Romania April 14 to 18, according to a press release the National Meteorological Administration sent to Ager press. Between 14 and 18, the predominantly southwesterly airflow will favor the movement of an air mass carrying Saharan dust particles from North Africa towards southeastern Europe, including over Romania. What else they mention here, it is that we will have strong winds valid until Wednesday morning in areas of 10 counties, thus between 14 April 10 a.m. and 16 April 10 a.m. in the counties of Bacău, Botoșani, Galați, Iași, Neamț, Suceava, etc. So Iași is already here. Wind gusts are expected to reach 50 to 60 kilometers per hour and so on. We were already in an event whenever they reported this. So I was asking yesterday night, so it could be any other difference in the Romanian people's life quality if they would earlier learn about the long persistent pollution event coming towards Romania. About earth care, I have learned, of course, late. It is not that I am indifferent. It is that just I don't have time, and we are only very few. Unfortunately, I think that many others yet don't care how much pressure this kind of air masses put on our health. So this is amazing. It tells us a lot, but I think that a more interesting part comes from what the researcher does. And I will start just to show you several data and information obtained by very hard work in the lab. Georgiana was the first obtaining information concerning the chemical composition of the aerosol particles in the atmosphere. So she measured all these ionic species, also water-soluble metals, and used many powerful programs and modeling tools in order to show what's the impact. What we have here from backward trajectory analysis, the origin of the air masses, clearly showing the contribution from Sahara, the contribution even from the oceans, seas, and so on. The distribution of the chemical constituents are showing exactly what you expect for such specific air masses. This, I think, is even more amazing because it tells you about sources, and in blue, we have secondary formation of sulfate. In green, we have nitrate contribution. In orange, we have whatever comes from traffic, and in yellow, we have whatever comes from dust. it is dynamic, it is complexity concerning the chemical composition, it is seasonality because we have for cold season, for warm season, and so on. Moreover, using again powerful instruments with the data, but the data always have to be very trustful, Georgiana could create this distribution map, and she was clearly showing over a larger scale how these pollutants are distributing. So we have for nitrate, we have for traffic and industrial, we have biomass burning and natrium chloride and also sea salt, which comes toward Romania. This was quite interesting because I think that it reflects mainly some of the mines from the eastern part of Europe. Georgiana went even further because she measured the water-soluble part of the elements of those metals, and she performed some non-carcinogenic and carcinogenic health risk assessments, which could be caused by aerosols elements, but specifically arsenium, barium, cadmium, cobalt, chromium-6, mangan, molybdenum, nickel, and lead. And chromium-6 is well recognized as being carcinogenic. She did this kind of investigation by studying heart and also by applying accurately the instruments she has used. United States, EPA from United States say that the acceptable carcinogenic risk level is 1/10 to the -6, which it would mean that one person in a million may develop cancer as a result of lifetime exposure to emission sources. Then we have a range, but this is not probably so important. What it will be important for the non-carcinogenic risk assessments, however, we identify by the hazardous quotient or hazardous index that it was smaller than 1, because 1, it is the acceptable risk value in this regard. And even though this percentual distribution shows us that arsenium, mangan, and nickel are leading actually the entire relative chemical composition, still the hazardous index and quotient did not require the attention. What actually required attention was the carcinogenic risk, because this, which is caused by inhalation exposure, and it is related to inhalation unit risk assessments. In our case, for specific elements, chromium and arsenium, it went higher than 1/10 to the -6. Actually, the carcinogenic risk at Iași, it was 7.12, 10 to the -6, and as chromium, it is from traffic and coal combustion, at least this, our positive matrix factorization runs, this was showing to us. Whenever we were trying to publish, we give recommendation in order for the administrations to look to implement something. But still, no one is interested in this kind of results. What else? It was interesting, also performed by Georgiana, investigation of new particle formation events at our site and what the risks are. Actually, new particle formation event, it will mean that with a specific instrument, you can measure particles which are not 1 micrometer in diameter, which are from 10 nanometer in diameter or 14 or 15 nanometers. So 3 orders of magnitude smaller than 1 micrometer almost. And she did some measurements. Unfortunately, the instrument gave us some problem due to the humidity outside. For few days during warm period and few days during cold period. These results appear after the treatment of the data, so it is a lot of work. But what it is important, it is that she ran again by using the Commission on Radiological Protection model. This model, she used it to estimate the deposition fluxes, especially for the particles with diameters between 10 and 400, almost 50 nanometer, especially for those which go into in various regions of the respiratory system, head airway, including nasal, pharyngeal, and laryngeal passages, tracheobronchial, alveolar, including pulmonary. The model was applied for nose breathing at average 3 exercise levels: sitting, light exercise, and heavy exercise, both for males and females, and with respiratory parameters for which she paid also attention. And what it was interesting to find that the alveolar region of the lung, of the human lung, is the main deposition area for particles in all categories of events at the Amos site. And actually, this is what our figure here down it show it to us. Always in the alveolar region, we have higher contribution of these particles from the new particle formation event. The one which is near, it is the total, so it is a sum of the alveolar, of the tracheobronchial, and of the higher airway region. Somehow our conclusion it was that the ultrafine particles seems to be predominantly deposited in the alveolar region. So actually there is a potential of great health risk hazards during a new particle formation event. What else we did in our lab? Apart measuring ionic constituents, because all those informations were based on ionic constituents and metals or elements, and of course the modeling she did. Cornelia started to look further into the organic part of the aerosols. It is a lot of work in this regard to prepare the samples and to get information. But it is interesting to see how much information you can get. Here we have a signal from a specific instrument which show us only on a specific frame many compounds which are included in the molecular tracers of secondary organic aerosols, and these are of biogenic origin. So we don't speak yet about anthropogenic. This is even worse because these are polycyclic aromatic hydrocarbons, and for sure about this you have heard because this mainly comes from incomplete combustion. I will come across them again later. I go further in order to show you how much treatment you have to apply to the data you are getting in a lab. You see, you have data from instrument, you have then this is a specific program, MZ-Mine. So Cornelia followed all this route from here to here, and then she did calculations for specific parameters in order to learn about the aromaticity, about the oxidation state of the carbon, and so on and so forth. However, the finality was quite interesting to learn that from specific signals, you can learn out about the existence in the Iași atmosphere of about 400 plus minus something chemical constituents over the summer period, and more than about 850 chemical constituents over the winter. Cornelia went even further, and she looked by, these are kind of analysis, it is called Van Crevelen diagrams, for the atmospheric aerosols from our urban area. This also I found it to be amazing at the period she finished the analysis, because it was telling us that over the year, we have a change actually in the dynamic of the composition, chemical composition. And you see that always over the cold season, the cases are becoming worse because A, it is here, it is the aliphatic region. B, it is the fatty region, so to some regard unsaturated. C, it is the aromatic region. But look what is in this, probably 100 and 1,000 of points reflecting a chemical constituent, which actually are acids, carbonyls, alcohols, esters, peroxides, and so on. With the analysis, Cornelia went further. She classified the chemicals into semi-volatile oxidized organic aerosols, low volatile oxidized organic aerosols, and many others. And on the polycyclic aromatic hydrocarbons, both Cornelia and Georgiana ran again the specific instruments in order to see the impact on the human health for this carcinogenic risk, taking into account that many polycyclic aromatic hydrocarbons have this dramatic effect, especially benzoalpha-pyrene. It is well known and included in many in the Environmental European Agency regulations. So they ran this for respiratory deposition doses for all the adults in each region of the respiratory tract, the upper airways, the tracheobroncholar, the alveolar region. And since we were measuring for each specific stage, they couldn't get information related to the fact that the deposition, it is influenced also by the dimension of the particles, because you see, it is not a smooth distribution, it is not a Gaussian distribution, but we have some peaks, and this might be related to specific mechanism of action. And a considerable concern arises from the fact that the highest respiratory deposition doses for adults were found again in the alveolar region. So this means that the particles go deeply inside our lungs, where absorption of polycyclic aromatic hydrocarbons through the inhalation route is favored. For the carcinogenic risk values for the inhalation, this part, ingestion and dermal contact pathways associated with polycyclic aromatic hydrocarbons concentrations were also undertaking this kind of investigations. With the red line, they say that this is the acceptable risk level, which is regulated. And of course, 110 to the -4, whatever it is under, it is not acceptable. In our case, so in Iași area, ingestion seems to be the major pathways of polycyclic aromatic hydrocarbons exposure for adults. And for example, if the total cancer risks for spring and summer are lower than the tolerable level, the sum of carcinogenic risk for ingestion during winter and autumn are at an unacceptable level. It is both of them are above 10 to the -4. And the dermal pathway seems to be the second, this one, the second most important route for PAX exposure, with values for the carcinogenic risk, but as a sum, I insist on this, which is 1 order of magnitude only lower than those for the ingestion route. And this is also important. We find here that species of greatest concern of the interest in the metropolitan urban area from Romania, Iași, we mean, is benzoalpha-pyrene, benzo-biphenanthrene, indinophenol, benzoalpha-anthracene, and so on. It was interesting to look at other specific constituents in the aerosols, in the atmospheric aerosols. Never I could believe that we can have something like this, but 3 years ago, in my mind, it started, what about bioaerosols also here in Iași? So actually, with Christina, one of our PhD students, We started, even though it was a very hard work in order to obtain the data, but this is a result of samples collected from AMOS with specific culture media, Luria bertani for bacteria, Saburo for fungi, and of course growing and developing in an appropriate way, with isolated colonies. And these are information which Cristina got here in Romania. This is for a bacteria of gram-positive type, Coccobacilli, at the cell level. Another gram-positive bacteria at Koch level. This actually at the beginning she said it might be, it is a yes, but I am not sure. She said probably it's a bacteria finally. And with blastospores actually. And for this one, she told me these are fungi with hyphae, and she was really happy whenever she observed the conidium form. Even though we tried several times to develop collaborations here in Romania in order to make, PCR and qPCR are essential in order to obtain information, because, okay, you see the colors are beautiful, but if you don't say what they are, it is useless with what you are doing. Finally, we went to Hungary, and thanks God, I am really grateful for their professional. We learned out that these are only several microorganisms. We had to deal with Arthrobacter species coming from the dust, Saharan even dust, Planococcus wiggly, which comes from the chicken feces, Aureobasidium, which is not a bacteria, it is actually a yeast, and this is not exactly, you see that it's species 1. And for fungi, we have Alternaria destruens, which actually it is related with sediments from the marine area. And you remember all those back trajectories showing from where the air masses were coming to Iași, to our place. So concerning these bioaerosols, actually, we said, okay, we can do something in the lab. We built up a micro chamber where we wanted to put the Petri dishes with isolated colony, but we were facing some problems. Then our second trial was with headspace analysis. It didn't went well, and finally, since we had an idea how to deal with Teflon bags in order to open them, to put the Petri dishes with the isolated bacteria or fungi inside, and then to seal again so that you will not have air intrusion from outside. We deal to do measurements with our instruments acquired within the Recent Air Center. It is called SIFT. And what you get a lot of information, quite useful. Okay, these are some mass spectra for Agrococcus citreus bacteria and the Fusarium species from a fungi, but not this. Okay, then you process the data, you obtain some info. This Venn diagram, it tells you from the bacteria how many chemical species are common, how many are different, and so on. I think that this is the best, because actually you get information about the dynamics during the growing process of the bacteria. So you see, for more than 60 hours, what did happen during the development of the specific bacteria? This is an example only. It could be measured in the gaseous phase, and this is hard working, because this first point, it means, okay, putting the Petri dishes, taking measurements, you see that we have even the uncertainty estimated, and then you put back, then you go in the lab to ensure appropriate conditions for development, for the microorganism development. This is a part which we didn't use yet for publishing. We have still work to do, but it is quite interesting to observe that we have a lag phase here at the beginning of the experiment with very low emission. I am sorry. We have an exponential phase, which is a faster increase. Probably the enzymatic activity, it rised, and also the biomass. So abundant emission, and the stationary phase, which actually it will reflect ending the enzymatic activity and cessation in emission. And data validation, okay, for me, I think right now it is kind of joke. Still, I love to work. Still, I love aerosols, and for the kids and for their hard work, actually, I was very pleased when I could see that they succeeded to publish the results. So whatever I was showing to you, apart this last one from the microorganisms with SIF, they were published in very good journals. And finally, even, you see, I didn't put conclusion because this will require quite a lot of discussion. I want to thank you. I want to thank to my students. I want to thank to everyone which actually would like to understand what it is around us in order to undertake measure and to improve somehow our human life. And you know, indeed, I am a teacher now. Probably I am going toward 30 years of experience. I don't know if I have enough, but this is quite interesting. And this, I love it, I think, for more than 40 years, because for me, this kid is telling Eureka. It means that he discovered the truth. He is happy. Even though it is difficult to go further, everyone and each of us, I think we are undertaking all these challenges. Also, she is very happy and enjoying a greenish life. This is the infinite column of Brâncuș from Romania, and I think that there is still hope that something will go toward the right direction for us. Thank you very much for